In this activity, we'll be creating a program that utilizes the map combinator. The map combinator is used to transform one value into another. Once you're ready, let's open up Visual Studio Code and get started. Once Visual Studio Code loads, navigate to your activity directory. We are on activity 21, so double-click on A21. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. Okay, let's get started. As we can see, this topic is about the map combinator. The requirements are simple. Given a username, create and print out a user struct if the user exists. Our notes indicate that we need to use the existing findUser function to locate the user. We need to use the map function to create the user. And then lastly, we just need to print out the user struct if found, or a not found message if it was not found. Since we already have existing code created for us that we need to be utilizing, I'm just going to go straight into the main function and start writing the program. As we can see with our findUser function, it accepts a name as a string slice and returns an optional i32. The i32 represents a user ID, so if the user exists, we'll get their ID back as an option. We have 3 users in here, Sam, Matt, and Katie. I'm going to search for a user that already exists first, and then after that, we'll try a user that does not exist. I'll create a variable called username, and we'll start off with Sam. Next, I'll create a variable called user, and we'll call the findUser function. The findUser function accepts a string slice, so I'm going to pass in the username. I then am going to call the map function on the return value of this function. We can call the map function directly after the findUser function by chaining function calls. Chaining function calls just means you have a dot and then the name of the function. We can do this on findUser because it returns the option type, and the option type has the map function defined already on it. The map function accepts a function as its argument, and we can either provide it a function or a closure because they both serve the same purpose. It's possible to define a function here and then pass it in as an argument, or we can define our closure directly here and then use that. I'm going to define a closure. Since this is a simple operation, we don't need a whole function dedicated just to it. To create a closure, we use 2 pipes. These pipes are equivalent to the parentheses in our functions. So with the function, between the parentheses, we include the function arguments as well as the type. With our closure, we're going to do the same. So our argument to the closure will be the user ID. We don't need to specify a type with closures because the compiler is able to figure out the type on its own. In addition, the compiler can also figure out the return type, so we don't need to specify which type it returns as we do with functions. What I'm going to do in the body of this closure is just create a new user. As we can see, the user struct as a user ID and a name. I'll pass in the user ID directly, and the name can be the username, and we need an owned string in this case. As we can see, the user struct requires an owned string, and when we create the string like this, it is a borrowed string. So this just takes ownership of the string so we can create the structure. Remember to end all your let bindings with a semicolon, otherwise you'll get a syntax error. The next thing we need to do is print out the user struct if found, or a not found message if it is not found. To do that, I'm just going to match on the user, and if we have a user, then we'll just print out the structure itself. If there was no user ID found, then we'll get none, and we'll just print out a message, user not found. And that should complete our program. Before running this program, let's unpack what's going on. We have our main function. We are creating a username by creating a string slice. This will be the username that we're searching for. We then are creating this user variable using a combination of different things. I'm going to change up the formatting here so it's a little bit easier to read. Depending on the length of the code, the Rust formatter will automatically format it differently. I've manually formatted this so we can follow it more easily. So here we're creating our variable, and we're calling the findUser function with the username that was defined here. The findUser function will return an optional i32 which represents the user ID. It's an option because we may or may not find the user depending on what was entered. We can see we only have 3 users, so if any other name is typed in, we'll get none, but if one of these 3 are typed, we'll get an ID. After we call this findUser function, we then call the map function on the return value. The return value is an option, and the option type has the .map function implemented on it. The map function accepts as its argument another function. When you have a function that accepts a function, you can either use a real function as defined here, or you can create a closure as we did here. The closure accepts arguments just like a function does, and the arguments are enclosed within pipes. In this case, the argument will be the type that's within the option, so it's an I32. So this user ID is an I32 value because we're mapping into the value of this option. Within the body of this closure, as seen by these curly braces, we create a user struct, and the user struct is just seen up here. It simply has a user ID and a name. We create the struct using the structure creation syntax by just using curly braces, specifying the user ID. The user ID variable is the same name as the structure field, so we don't need to have the colon with the name of the variable. We then have the name field, and we're reusing the username variable defined here. It's a borrowed string, so we just take ownership of it. That way it can be stored properly in the struct. We then hit the end of the closure body as defined here, and then the end of the arguments for the map function. This entire block here is all considered one function parameter to this map function, as we can see by the parentheses. So these parentheses here are the beginning and end of the arguments that the map function accepts. And this entire portion is the argument to the function, which is just creating a closure right here. This is called creating a closure inline. And we call it an inline closure because it is in line with our map function arguments versus if we created a function here and then just gave the name like we have been with our normal functions. Closures are convenient though, since you don't have to keep creating new functions here in the rest of your program. I'll save this and we'll run it. To run the program, go to Terminal, New Terminal, run activity 21, so we can type in cargo run -q -bin A21. And since we search for a user that exists, the user printed out with the ID and the name. I'm going to type in a user that does not exist. We'll try it again, and we should get user not found, since Amy is not listed in this list of users. As we can see, we got user not found as expected. This concludes the demo on the map combinator. I'll see you in the next presentation.